Hi, I'm Bob. Welcome back to the 5 Minute Econometrics, a program that provides fundamental concepts and estimation methods to econometric learners. Today, we will explore interaction terms in a regression model. Part 1 is about how it relates to marginal effects. We often add an interaction term to a linear regression model. According to the type of variables that form the interaction term, whether they are continuous or binary, we can capture various effects of the explanatory variables on the outcome variable. When the explanatory variable we are interested in is a continuous variable, we can use the interaction term to capture a non-constant marginal effect of the variable of interest on the outcome variable. In other words, the marginal effect is allowed to change. For example, in this model, we want to know the partial effects of education on wages, which is also known as the return to education. We include the years of schooling and parents' income in the model and find that the return to education is about 11%. That is to say, one more year of schooling increases the workers' wages by 11%. We wonder whether the return to education changes with family background, such as parents' income. We can add the interaction term between years of schooling and parents' income to the model. The marginal effect of years of schooling on wages is no longer constant, but depends on parents' income. In the sample, the parents' income is the average of the parents' incomes during the workers' childhood years, which reflects the workers' family background when they grew up. In Stata, the pound sign is for the interaction. We treat the variables as continuous variables, so we add a prefix of C dot before them. Here are the OLS estimates. To determine how the marginal effect of schooling on wages changes with parents' income, we first find out the percentiles of the log parents' income. The median, or 50th percentile, is 10.3. The 5th percentile is 9.27, and the 95th percentile is 11.21. Then we can calculate the return to education for these three different percentiles of parents' income. For instance, we want to know the return to education for workers reared by parents with a median income. A simple calculation leads to 0.108. We can also use Stata's margins command with dydx and add options to perform the computation for parents with 5th percentile, 50th percentile, and 95th percentile income. They are 0.099, 0.108, and 0.116 respectively. We conclude that the return to education differs by family background. Education has a larger effect on wages for the workers who grow up in wealthy families or are raised by high-income parents. Another method to find the return to education for different percentiles of parents' income is to construct a model like this. The coefficient of schooling, will be the return to education for particular groups of workers. It leads to the same results as the first method. This is the case when the interaction term is constructed by two continuous variables. The second case occurs when the interaction term is formed by one continuous variable and one binary variable, with the variable of interest being the continuous variable. We use the same sample to show this case. We divide parents' income into two groups and define a binary variable that equals 1 if parents' income is high and 0 if it is low. The marginal effect of years of schooling on wages is beta 1 for workers growing up in low-income families. It is beta 1 plus beta 3 for workers who are raised in high-income families. The interaction term helps to find a return to education for these two different groups. In Stata, the double pound size represents the level terms of the variables and their interaction term. We find that workers from high-income families tend to have a higher return to education. The difference in the return to education is the coefficient of the interaction term. The difference is statistically significant at the 10% level. Today, we have discussed how the interaction term in a linear regression model illustrates a non-constant marginal effect, which allows the marginal effect of an explanatory variable on the outcome variable to change with another explanatory variable, such as the workers' return to education varying with their parents' income in our example. Thank you so much for watching this video and subscribing to my YouTube channel. I hope it helps and see you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.